Artificial intelligence is using a lot of energy. It uses more energy than many small countries. Every time we ask an AI to write a story or make a picture, it uses electricity. This is a very big problem for our planet. The computers that run AI get very hot. They need huge buildings with strong cooling systems to work. These buildings are called data centers. As AI gets bigger and smarter, its need for power grows and grows. This is not good for our world. This growing energy use is a hidden cost. It makes our electricity bills higher. Experts are worried. They say that by the year 2030, AI could use as much electricity as a whole continent. This is a shocking amount of power. It shows that we cannot continue on this path. We need to find a better way. Scientists have a new idea. It is called a thermodynamic computer. A thermodynamic computer is a device that uses the natural movement of tiny particles to do calculations. Think about a glass of water. Inside, tiny particles are always moving around. This new computer uses that natural movement to think. It does not need to force electricity through wires in the same way our current computers do. Instead, it guides the natural flow of things, like a gentle river guide steering a boat. The core idea is simple but powerful. Instead of using electricity to flip switches on and off, this computer uses heat and the natural tendency of things to mix together. It is made of a special gel. This gel has tiny channels, like little roads. Inside these channels are saltwater ions. By applying a very small electric field, scientists can guide these ions through the channels. The way the ions move and spread out becomes the calculation. To understand this new computer, let's compare it to what we use now for AI. Most AI today runs on artificial neural networks. They have layers of connected neurons that pass signals to each other. When an AI learns, it changes the strength of the connections between neurons. Instead of digital neurons, it has a physical network of tiny channels in a gel. The ions moving through these channels are like signals in a brain. When the computer is given a problem, it applies a small electric field. This field acts as the input. The ions then naturally move and spread throughout the network of channels. They interact with each other as they go. The ions do not just go in a straight line. The thinking happens as the system settles. The final arrangement of the ions in the gel represents the answer. It's less like a series of rigid steps and more like a crowd of people finding the quickest ways out of a stadium. The thermodynamic computer lets physics do most of the work for free. The energy savings from this new computer are truly huge. It is not just a small improvement, it is a giant leap forward. Researchers have found that a thermodynamic computer could be up to 1 million times more energy efficient. That's compared to the best digital computers today for certain AI tasks. This number is so big it is hard to even imagine. A single large data center can use as much electricity as a small city, about 50,000 homes. Now imagine powering that whole data center with the energy from just one home, or from just 2 homes. That's the massive reduction we're talking about, like replacing a giant noisy power plant with a small quiet solar panel. It could put powerful AI into tiny devices running on tiny batteries, medical sensors, environmental monitors. It could make self-driving cars much more efficient. The impact on global energy use would be enormous. It unlocks a future where AI's power is no longer limited by its thirst for electricity. Let's look at one clear example: creating images with AI. Today, when you ask an AI to generate a picture of a cat wearing a hat, it goes through a complex process. The AI starts with a screen full of random noise, like the static on an old TV. Then, step by step, it refines that noise. In each step, it makes millions of tiny calculations to change the pixels. Now, let's see how a thermodynamic computer would do it. That request is turned into a pattern of electrical voltage on a gel. The ions in the gel begin to move and diffuse. As ions reach stable positions, a pattern emerges. The final image. The device doesn't calculate pixels one by one. The whole image appears as the system reaches equilibrium. The thermodynamic computer is mostly passive. It uses a bit of energy to set up and a bit to read the result. It's like climbing a mountain versus rolling a ball down a hill. The result, a beautiful image created with a tiny fraction of the energy. If this technology works on a large scale, it could completely change the world of AI. First, it would make AI much greener. By cutting energy use by a factor of 1,000,000, we could drastically reduce the environmental impact of artificial intelligence. Second, it would make AI cheaper and more accessible. By making AI so much more efficient, the cost of training and running these models would drop. Smaller groups could afford to experiment. More universities and startups could participate. Third, these computers could potentially solve certain types of problems much faster. We are currently hitting limits. However, we are not there yet. This technology is still very new. Scientists need to figure out how to build them bigger and make them reliable. They also need to learn how to program them for a wide range of different tasks. It will take years of research before we see thermodynamic computers in our data centers or in our pockets. But the promise is too great to ignore. The journey of technology is full of big ideas. The thermodynamic computer is one of the most exciting new ideas in a long time. It shows us that there might be a completely different path for the future of computing. Sometimes the best solutions come from looking more closely at the world around us. The natural world is full of powerful computational processes, from how a plant grows toward the sun to the way our own brains work. This research taps into that natural power. This is not just a small improvement, it is a radical new way of thinking. It offers a future where we have the amazing benefits of AI without the damaging environmental cost. The thermodynamic computer offers a beautiful and elegant answer. It is a hopeful sign that we can build a future that is both smarter and more sustainable. We are at the very beginning of this new chapter in computing. So, this is a space to watch closely. The quiet, natural process of ions moving through a gel might help us build a better world for everyone.